So, good day. We'll continue to discuss the index properties of soil, part 2, actually, the previous slides is more on the chemical properties of the soil particle, no? It's chemical, to say combination, elements, and minerals. But will not tackle that one, no? Instead, we move on to the grain size and grain size distribution. So, the soil texture is its appearance or feel, and the texture of soil is its appearance or feel, and it depends on the relative sizes and shapes of the particles as well as the range of distribution of those sizes. So we have this standard now from the USCS, or this is Unified Soil Classification System, and from the British standard used by Hong Kong. No, there is this boundary, from between the coarse grained soils and the fine grained soil. So we have the two types of coarse grain, the gravel and sand, and the fine grain, the silt and clay. So ang boundary, between the coarse grain soils and fine grain soils from the USCS is 0.75 millimeter, while from British standard 0.06 millimeter. So we can distribute the soil through sieve analysis for coarse grained soil, and hydrometer analysis for fine grained soils. We have also this particle size distribution. So, maklasify siya as boulders kung the size of the soil is more than 60 millimeters, and between this range 2 millimeters to 60 millimeters is gravel. Then 60 micrometer to 2 millimeters is we can classify it as sand, and 2 micrometers to 60 micrometers silt. Less than 2 micrometers is the clay. Each class is subdivided into coarse, medium, and fine. For sand, we can further classify sand as coarse sand kung within siya sa range 600 micrometer to 2 millimeters, and medium sand 200 micrometer to 600 micrometer, and fine sand kung between sa 60 micrometer to 200 micrometer. So the classification boundaries either begin with a 2 or 6. So we have this table for the another particle size classification of the different organization or standard. Say we have MIT, or the Massachusetts Institute of Technology. So they classify the soil according to this standard. Then USDA, or the US Department of Agriculture. So lahi-lahi sila o classification sa soil, for example, kaning sand 2 to 0.05 millimeters, while ang kaning MIT 2 to 0.06 millimeter. While ang AASHTO, or the American Association of State Highway and Transportation Officials, maupod niyang iyahang classification sa soil, and the USCS, or the Unified Soil Classification System, by the U.S. Army Corps of Engineers and U.S. Bureau of Reclamation, American Society for Testing of Materials, maupod ni iyahang classification. Yes, another classification for the grain size, no, of soil. So we have the USCS and the British Standard. We have the gravel, sand, silt, and clay. So naa siya boundary, no, values. So between the silt and clay, the boundary is 0.002 millimeter. And the silt and sand for BS, now 0.06, and for USCS 0.075. For sand and gravel, the boundary for USCS is 4.75 millimeter, and for British Standard is 2 millimeters. And we have also this table, no, dili kay siya klaro, but this is the classification also from ASTM, D472 and hindi siya maklaro, and AAS2, USCS and British Standard and MIT, no. So naa siya, this also a classification like for boulders, the size, no, between boulders and cobbles 300, no, millimeter. And yeah, try to zoom, no, zoom out to clearly see the values. We have this particle size distribution, no. Data often presented as particle size distribution curves with logarithmic scale on the x-axis. We have this particle diameter on the x-axis, millimeter, in logarithmic scale, and the percent finer, meaning percent finer is the percent nga ni pass sa sieve, specific sieve, no, that is percent passing also, this percent finer. The S shape, but some conventions of curves going left to right, others opposite way around. So other S shape is this shape, no, ingani nga shape. Others is pabalian, no. So depende sa arrangement of the logarithmic scale and the x axis, but kasagara is ingani nga shape, no. So we have this clay, boundary between the clay and silt is this one, that is I think that is 0.0, if I'm not mistaken, 0.002, no. And between the silt and sand, the boundary is this 0.006, no, siguro. So the problem is that clay is used both as a classifier of size as above and also to define particular types of material. Clays exhibit a property known as cohesion, the thickness associated with clay. The problem with clay, no? Or the general properties, gravels, the permeability is of the order of millimeter per second, no. Between the soil, no, the gravel prohibits, not prohibits, exhibit koan higher permeability because of the shape of the gravel nga dagko, so create siya og dagko pod nga lusutanan sa tubig, no, unlike sa clay which is very fine. So ang iyang permeability is this, it is 10 to the power of -7 millimeter per second or less. So dili kay dali mulusot ang water sa clay, that is why the value is to the negative power, no. Compressibility of the soil increases as the soil particle decreases. So compressibility, so more ang compressibility sa clay, no, because particle size is gamay. then permeability of the soil decreases as the particle size decreases. So that is why clay, it is 10 to the negative something millimeter per second, because of its finest particle. Then maglisod og lusot ang water. We have the different sieve sizes. From the US standard sieve sizes, we have the sieve number 4 to 270, or with its corresponding opening or diameter, no? For example, the sieve number 4, that is 4.75 millimeter, so on and so forth, until 270, that is 0.053 millimeter from DAS 1998. We have also this metric sieves from the British standard, and the construction material is the perforated steel plate with a square hole, no? With its corresponding size, this one, and but the common, no, that we use even in our laboratory in the engineering is this US standard sieve sizes. This is the sieve analysis, no? For coarse-grained soils, we can classify the soil through sieve analysis, or through using sieve. And the finer grained soils, or the silt and clay, mas accurate kung magamit ka og hydrometer analysis. The continuation of the grain size distribution, we have this effective size. The effective size is the D10. This is the diameter, no, of the, or the effective size that will pass, that have, or that has 10% finer, no? So for example, the 10% finer of the well-graded distribution of soil. So asa man ang 10, this one, di ba? Imo na siyang i-project diha. Then using this curve, no, the well-graded curve kani, imong i-project diha. That's why the effective size, the D sub 10, is 0.02, no, millimeter. We have this different shape, no, or behavior of the distribution of soil. We have the well-graded, the uniform. So kung well-graded, meaning in every sieves na ay ma-retain, no, in every sieve number naa siya significant amount of soil nga ma-retain or nipas. While ang this uniform is uniform gradation, or a uniform distribution. Ang pasabot ani is that uniform, meaning ang size niya kasagara daghan ang kadtong, sa example, sample of soil, daghan ang, for example, this one, daghan ang within this range of grain size diameter. I mean, diri na distribute ang diameter of the soil, meaning within diri ra kani nga part diri. Wala siya na distribute o tarong. So ang kasagara nga present sa imong sample sa soil is within this range of sizes, no? Munang uniform. Murag nagkapari-pareha ra sila og, almost pari-pareha ra sila og sizes. That is the meaning of the uniform. That is why ingani ang iyahang curve. And for the gap graded, no, ingani siya. This is the behavior. Wala na tarong og distribute, no? So that is why kung well graded ka, smooth ang curve or like the S shape nga ingani, well graded. We have this for the a description of the shape. We have this D sub 10 or the effective size. For the well-graded example, the well-graded in the previous slide, no, above kanisha, we found out that the D sub 10 or the 10% passing, kung siyang i-project, the effective size is 0.02 millimeter. And for the D10, 30% passing, kung 30% passing, kung imo siyang tanawon, where is 30, diba? This one is a 30. Imo siyang i-project for the well-graded, the size is 0.6, no? Millimeter. And for the D60, that is 60% passing, this 60% passing, no? Or finer. The size is 9, no? 9 millimeter. Since this is 10, then wala na siya kabot sa 10, so 9 millimeter, no? To determine the coefficient of uniformity, that is C sub u, no, denoted as C sub u, that is equal to D60 or diameter at 60% passing, the size of the soil at 60% passing, divided by the size of the soil at 10% passing. That is 450. This is for the well-graded, no? And the coefficient of curvature. So this parameter, no, we'll use this one as criteria to determine the what kind of soil is example sa inyong sample, no? Ma-determine kung unsa siya nga soil, kung ba siya sand or silt, no. Then the coefficient of curvature is this formula: C sub C is equal to D30 squared over D10 times D60. This is 30% passing, diameter of the soil, 30% passing divided by D10 times D60. So the answer is equal to 2. For the criteria, no, criteria for the well-graded soil, the C sub C should be this range, or the coefficient of curvature, and C sub u, no, for gravels is greater than or equal to 4, no. And for sands, the C sub C, the coefficient of curvature is still now within 1 to 3, and C sub u is greater than 400, greater than or equal to 6. This is for sands. Notice that the answer, no, for the coefficient of uniformity and coefficient of curvature greater than 4 and 6, and the coefficient of curvature is 2 within this range, meaning the soil sample that you have, no, is composed of the gravels and sands. Question: what is the coefficient of uniformity for a soil with only one grain size? No? With only one grain size, meaning only one grain size since naa siya sa kasag-ani ari, only one grain size is kaning uniform. The shape of the curve is uniform, no? Because murag halos sa parehara sila og grain size mo ng uniform. So what is the answer for this? The answer is what is the coefficient of uniformity for a soil with only one grain size? For example, because C sub U is equal to D60 over D10. So, kung pareha ra o grain size no ang nipas 60% and 10%, the answer is 1. So, the graph will look like this, no? Only one grain size. Raman. So, this is the grain size distribution curve, no? Which is vertical line. Alright. This sample problem for a soil with D60 equal to 0.42 and D30 0.21, D10 0.16 millimeter, no? Calculate the coefficient of gradation. So the coefficient of gradation, there are two coefficient of gradation. The C sub U, the coefficient of uniformity, and the coefficient of curvature, no? The C sub U and the C sub C. What are these, no? What are the answer for this? The C sub U is equal to D60, 60% diameter of the soil, 60% passing, and over the 10. Sorry. Mali. D10. So for this, D60 is 0.42 millimeter over D10 is 0.16 millimeter. So pila na siya. May right? Sakto ba ang formula? 0.42 divided by 0.16 is 2.625. D60 over D10, yes. Sakto, no? That is 2.625. No unit because these are coefficients, no? And for C sub C, or the coefficient of curvature, that is D30 squared over D60 times D10. That is 30 is 0.21. Sorry. 0.21 squared over 0.42 times 0.16, no? Is the answer for this. Answer is 0.6 0.656, no? Ito. D60 over D10, D30 over D10. So these are the answers. Okay. We have to answer this problem. Following are the results of the sieve analysis. So this one. Determine the percent finer than each sieve size and plot a grain size distribution or distribution curve. So, percent finer ang y-axis, then the x-axis is the diameter in logarithmic scale, no, or the size of the soil. Then determine D10, D30, D60 from the grain size distribution curve, calculate the uniformity coefficient, and calculate the coefficient of gradation. So for letter A, we are asked to determine the percent finer, no? So to answer this one, we have to right. We have to add the column, no, for this one. We have the cumulative. This one is for the cumulative. All right. Okay. I'll try to discuss, no, this will be your assignment, this one. Answer this one. And I'll try to discuss, no, an example which is from the book nga naa na siya daan, no, para dili tapulan man ta, so natay pagkatapulan. Okay, let me share. Sorry. So this one. So this one, this is an example. Example, following are the results of the sieve analysis. Make the necessary calculations and draw a particle size distribution curve. So we have this sieve number and mass of soil retained on each sieve, no? So the following the following table can be now prepared. So we have to add additional column for this one. So for the US sieve, no, the opening is 4.5. This opening is already available, or we discussed this one in previous slides, no, for the US sieve, no, standard. So for the 4 sieve, 4.75, for the number 10 sieve, 2 millimeter, and for the until number 200 sieve, that is 0.075 millimeter. No, gamay na kay na siya. Then the pan that is katong pinakalas nga wala siya opening, no, katong last, that is the pan. Kung inyong nakita sa inyong video, you're already done with your CE37, no, construction materials and testing. So I think I don't know if na-handle ba tamo tanan, but yes, the pan is the last portion sa sieve nga mo receive, no, sa katong the smallest grain size or soil size. So according sa table, the mass of soil retained on each sieve is this one. For the opening, no, for number 4 sieve, 0. For number 10, 40, 60, 89, 140. Then sa pan, siya na-retain nga 12 grams, no? 12 grams. For the cumulative mass retained above each sieve, no? This is the gram value or the mass value nga na-retain above each sieve, the cumulative mass. So for example, this one, no, the cumulative mass is actually the amount of the previous sieve plus the amount sa katong nagsunod. So for example, kani siya for number 4 sieve, that is 0. So 0. For number 10 sieve, 0 plus the amount 40. No, this meaning this is the cumulative mass retained above this sieve, no? And for the number 20, that is 40 plus the mass retained on each sieve is 60, so nang 100. Then for the number 40, that is 100 plus its mass retained 89. So, manang 189 for the number 60 sieve, 189 plus 140. So, manang 329, so on and so forth. So, that the summation of the masses, no, total is 729 grams. Right? So, the percent finer, this is the percent nga ni pass sa each sieve, no? The formula for that one is the summation minus the column 4. This is the column 4 divided by the summation times 100%. Diba sakto? No? Try to analyze to get the percent finer or the percent nga ni pass atong specific sieve, that is the summation, the total mass minus the column 4, the cumulative mass retained above each sieve divided by the total mass. So for the column 5, that is 729 grams minus column 4, that is 0, divided by 721 times 100, no? That is why 100. The meaning of this 100 is 100% all of the soil ni pass ani nga number 4 sieve ng 100%. And next one, for the number 10 sieve, that is 729 minus column 4 minus 40 divided by 729 times 100. The answer is 94.5%. That is, this is the percent nga ni pass sa number 10 sieve. Meaning, 94% of the total soil amount mo ni siya ang nipas, no? Hangtod mahuman nimo sa pan, no? And sa pan, 0%, meaning kay pinakalas naman to, walay nipas sa iha, kaya wa mo to pining, that is why 0. No? Try to solve this one, the column 5, so that you will be familiarized now how to solve, how to prepare this table. And then, we will now construct a curve. So, the curve for this one is this one. So, the percent finer, no, this is 0 to 100%, and the x-axis is the particle size in logarithmic scale. Actually, kani siya, nabalin ni siya mo nang the curve is like this, no? Pataas to paubos. But in our discussion in the handout, paubos, paana to siya diri, no? Paubos to pataas to siya. But yes, you can do also this one. But I would like to, para ma-uniform ta, is katong will adapt the paubos to pataas curve, no? Not this one. But for the sake of example, no, I mean, to answer or to draw the curve, for the example, this one, and percent finer on the y-axis and the opening on the x-axis in logarithmic scale. So, mao nang, then projecting the 60% finer to this one, then projecting to the x-axis, the D60 is 0.27 mm, D30 is 0.17 mm, is 30% passing, no? And D10 is 0.15 mm. Then get the value for the coefficient of gradation, the coefficient of uniformity, and the coefficient of curvature that we did earlier. right? This is the book, no, from this is the book of Das, right? Let's go back to so try to answer these questions, no, A, B, C, D, no, for as your assignment. All right. Okay. In here, so dire gibali na pud niya, no, from a bigger grain size diameter to the smaller grain size. That is why the curve is from higher to lower. You can also adapt this one, or you can adapt lower to higher, but for uniformity, okay, for uniformity, since nag-una man in the table, nag-una ang 4.75, so nag-una ang higher value of the diameter of the sieve to the lower. So for uniformity sake, or for our future exams, no, and assignment, kindly adapt this higher to lower curve, or the higher grain diameter or opening of the sieve to the lower opening. Okay. Sorry. Actually, this example has already an answer, no? But try to make this one on your own, this curve on your own, and try to answer, no, the additional column for the cumulative mass retained and the percent passing or percent finer, and make this curve on your own, and also answer the questions what is asked in this ABCD question. And this one, another example, the particle size, particles of soil are given in the table with percent passing, no? So already we have already percent passing, so automatically we'll create a curve or a gradation of soil. Calculate the uniformity coefficient C sub U in the coefficient of curvature C sub C. So from here, no, this one, percent passing is percent passing and the opening, no, to this curve. So in hitabuan ni is lower to higher na pud ang iyang curve, which is iyang gi-arrange as in the x-axis lower values of grain size diameter to higher values of grain size diameter. That is why ingani siya, no? And yes, then for the answer of the uniformity, coefficient of uniformity is D60 over D10, no, which we discussed earlier. The answer is this one. And C sub C, D30 squared over D60 times D10. So the answer is 0.063. The last two slides. This one is the last slide, no? One of the last two slides. Then the last is the end. In this topic, the index properties of soil part 2. For the engineering applications of the grain size distribution, it will help us feel the soil texture, what the soil is, and it will also be used for the soil classification in the next topic. It can be used to define the grading specification of drainage filter clacking. It can be a criterion for selecting fill materials, of embankments and earth dams, road sub-base materials, and concrete aggregates. It can be used to estimate the results of grouting and chemical injection and dynamic compaction, and effective size detail can be correlated with the hydraulic conductivity, describing the permeability of the soils in the Hazen's equation. The grains distribution is more important to coarse soils. So this is the important implications or applications of the grain size distribution. And okay. So bye class.